important. So let's go further what this containerization is and why in the world we need a containerization. So containerization is something came after virtualization, like after, so, but to understand it, it is very similar to virtual machine, but in the Docker, we call it a container. Now, in the company where you are, some people are developing software and some people are testing software, some people are using the software. So in that particular scenario, developer will develop something, and then the operation team or the testing team is going to test it and then pass it to the production team. Operation team is a production team where they are going to use it for production, right? Now, what was happening, I remember when I was being a software developer 15 years ago, 15, 16 years ago. And that time this Docker concept was not there. And what we had to, had a problem, like when I was a developer and I was working on pages developer. One scenario I remember that I was developing this mobile phone software. And then when it goes to testing team and they say that it is not working. So if code they are running, then it is not working. If they are running the exe, it is working. So on the real hardware, it is running. But on the simulator where they have to actually test it, it is not running. Some issue was there. And as a developer, we say, no, we have checked it. We have done the unit testing and everything was working fine in my system. There is a problem with your system. Then operating team or testing team will say, no, we are not getting it. So a lot of debate, delays and confusion, trust issue. Because in the industry, it is advised that developing team and testing team should work separately. They should not having the very close cooperation between a developing team and testing team. That is a requirement because the tester has to test the developers. So if too much in a friendly relation, then the bugs may go into the market. So the trust issue was there, right? Now, developer will give it to testing team say, okay, it is good. And then it will go to operation team and operation team will send it for production. So this was the scenario. And the problem of trust, configuration mismatch. So basic problem was configuration mismatch. Developer team will say, okay, you install this software. And then what will happen that the testing team will also install that software, but then still not running. Then the situation comes that, okay, the configuration means proper version number is not there. So this particular developing team is using some software package like A version 2.0, B version 3.1, C version 1.3, and this kind of version they were using. So what they did, okay, we write a requirement document and we say that, okay, all of this is you need to run it. Now what happened when when we are developing something, right? When we are doing development, sometimes we install certain packages, we install certain programs, we install something, and because of those comes with certain libraries, some dynamic link library, and our applications were running. And we, as a developer, quite some time we don't know that what are the inside DLL we are using, because sometimes we are using the operating system DLL, the version of developers OS, the version of testing OS, and the version of operating system OS. All may be different, or there is a mismatch in the update, and because of that, the system was not running. So this was the solution is what? Okay. So in 15, 16 years ago, what we used to do it, that we dedicate a system. Developer team will say, okay, this is the system, you have to use it. But that is not a really good scenario. We can do that if the developer and testing team is in the same premise. Often this is a problem, like sometime developer team is in Berlin and then the testing team may be in the Stockholm. And in that case, this is not, nowadays we do have the remote desktop connection. In past also the remote desktop was there, but that is not a very comfortable thing. So the solution was that, okay, we pass the software as well as whatever connected library it has and the operating system. Now, then send the complete software and hardware environment, including the exact software version, to the testing team. And with that, testing team will test it. It is working fine. Is it possible to send the OS? Means if I am working in my laptop, can I send my OS and whatever the condition my operating system has to anyone? I cannot share my laptop with anyone. But that was a demand that can solve it. People had tried to do with many ways. Dedicate a system, dedicate a server, dedicate a VM on which the developer will work, and the same VM will be replicated and that testing team will work. But this was not helping, and this was a problem with DevOps. And DevOps is a recent phenomena, is a kind of position in the industry. Earlier, this position was maintained or taken care by the system administrator. So now in past, there are hundreds of server used to have in a company, and to manage or thousands of server company has, and to manage thousands of server, we used to keep hundreds of system administrator. Now the system administrator and this configuration management and how to do everything solution has been given by the DevOps, and now you can 2-3 DevOps engineer can manage the platform for 1,000 servers. So automation is reducing the jobs, but it is increasing the efficiency. Now the VM came, right? We need to send the OS software, all the version. And now this software has to be tested on the different kind of platform. So let's say we have a hardware on which we installed OS, on which we are doing hypervisor, because it's a development platform. And so we created a VM and installed the Linux OS. We created the VM, we installed the Windows, we created a VM, we installed the Ubuntu, and we tested on all it. And can we send this complete image to the testing team? And if we send it, then they will be able to run as it is. So this was the requirement, and this could have solved the problem. So we are discussing everything, but not Docker so far. I have been talking about all this condition and issue, but where is the Docker coming? So the Docker is basically an advanced version of virtualization. We can do the virtualization, and on which our system can run and software can run with the same configuration and everything. But the same thing we can do in a better way by doing the containerization. So containerization, we can think like it is an advanced version of virtualization, and how the containerization is different from a VM creation or virtualization, we will know, and what kind of virtualization is a containerization, we will know in the next week lecture. So basically we have this hardware which has 8-core system, 16 GB RAM, 1 TB hard disk. We took the type 1 hypervisor. So we installed directly hypervisor on the hardware, and then we created a VM, and we need VM and Linux 2 GB is needed. Windows by default it needs at least 3.1 GB. So this particular VM with Windows 2012 server, 8 GB RAM, 200 GB. Now we need a VM with Ubuntu and we want, let's say, 8 GB RAM. Is it possible to do it for what this kind of virtualization platform? We already consume 8 and 2. 10 GB we have taken. We have 16 GB. Can we use 8 GB? So simple math says that no, we have already created a VM. Yeah, so the virtual memory, we have this 16 GB, right? So that is a RAM space we have. Now we created a VM with 2 GB. We created a VM with 8 GB RAM. Yeah, we can create the storage solution as a virtual memory. That is one way of solution, but RAM, we only have 16 GB. So with 16 GB RAM, we have 2 GB, 8 GB, 10 GB, we have consumed it. Now we need 8 GB RAM for this VM. In a normal scenario, for this kind of VM platform, it is not possible because we have already given a dedicated 2 GB RAM to this VM, dedicated 8 GB RAM to this VM. So now we only left with 6 GB RAM. And we need, this VM is asking 8 GB RAM. So this was basically causing hardware resource inefficiency. Means if this VM is not running, still this is occupying the 2 GB. If this VM is not running, still it is occupying 8 GB. And in this kind of scenario, the hardware resource utilization was not enough. And the industry wants much more better utilization. And to solve it, Docker came. So Docker is an advanced version of virtualization, and it is known as containerization. So in a virtualization, we call VM when we create a virtual machine, but in Docker, we call it container. Now we will know that how Docker is different. So you can understand this VM is like there are people who go to a buffet, right? There are people who go for buffet. If there's a buffet party, there are some people who will occupy it, a lot of food, and they are not eating it. And they are just, this VM is like this. It is not working and it is still occupying 8 GB. And once we say 2 GB, it is going to only use 2 GB. If it needs 4 GB, it cannot use, this VM cannot use 4 GB because 2 GB has only been given to it. We have to create another VM and then get 4 GB and then transfer everything, the state to that VM. That way we can do it. But in this VM, if it needs extra, we cannot give it. If it not using it, we cannot take back. So it is like we are going to a buffet, and some people have a tendency to, there are 25 items are there and they will take everything and they're not able to finish it. So this VM is like this, not using it, but the resource is going wasted. So what if we only have the VM and the hardware is not dedicated to them? And that is what Docker did. It created the VM environment, which they call it a container, but without dedicating a particular hardware. And it also solved the development and testing team problem. So that is a Docker. Docker, if you see, the icon is like this, which has a whale fish, and on which the container boxes are kept. So those are container, Now this whale fish indicates what the symbol actually is very meaningful. It actually explains the complete what Docker is, that it can sail from one place to other place, and it can move container from one place to other place, and whatever inside the container is there, and we can take things out from the container when that box and the box will still be there, but all the resources will not be inside it. Okay, so it is like that kind of concept and very meaningful symbol it is. One thing to note that container does not have operating system. When I say, some people will, if people know container, they will say no, container has OS because it is on Linux. It is based on Linux system, Ubuntu. It has an OS, but take my word that container does not have full OS. It does have a small OS. In the next week lecture, we will know how much OS it has. But container in general does not have OS. So now how it is running everything, software and all the management, how it is doing it. That is interesting thing. So we saw this VM, right? It has a hardware, it has a hypervisor, and then on top of it, we install the OS and a VM is there. What container is that? We have a hardware, 8 core, 16 GB, 1 TB, and then OS is installed. And on top, this Docker engine is installed. So when we call it Docker is basically a company name. Actually, what we are using is a Docker engine. So Docker engine is the actual word, but nowadays it is commonly called Docker. Docker is the name of the company. So we install OS, and on top we install Docker engine, and on top we create a container. Now container itself does not have any OS. So when it needs anything, it will take the OS task from here. And you can run container on any kind of system, Windows, Mac, Linux. But internally, the container is actually, Docker is built on the Linux. Next week, we will discuss more about it. So it takes the OS from here. Whatever hardware it needs, it will take from hardware. So let's say this container now wants 2 GB. It will request to the below hardware that I want 2 GB. The 2 GB it will take, and it will run the job, and then you remove the container. If this container, when it is not needed, if you need this container, then it say, okay, I need 8 GB. It will take from below. It will run the task, and you remove the container. The container configuration will be there, but container will not occupy it. We just remove it. We are not deleting the thing. This container, in the last scenario, it needed 8 GB. In this case, it will say, okay, I need 8 GB. It will run it. Now, when this will not happen, let's say this was running on 2 GB, this was running on 8 GB. Now, if it wants 8 GB, if all these are running, it won't get 8 GB. Then it will say, okay, the space is not there. We cannot create a container of size 8 GB. But that is a condition when all are running. Now, if this task has been done and it is not running, then it is simply going to release whatever resources it is taking. It is also going to release. So then this container will have even 16 GB, it can take it, right? So, and this container can have a window, this container can have the Ubuntu, this container can have a Mac. All different OS is there. Below, there can be one OS. It can be Linux. Then even with the Linux, you can create a window container. You can create the Mac container. But container works much better if we have a backbone as a Linux OS. Then it works, performance is better. Now, how it is different from other things like Docker, VMware, Azure, how they are different. So in a VMware, if you remember that it has a hardware, and then on top we install the hypervisor ESXi, which is a VMware hypervisor, and on top we do OS installation, and then we create a VM. Right? We do a VM, and that is a process. And whatever amount of resources it has, we can only use up to that in this condition. Same we go for Azure. we have a hardware, we install the Azure Hyper-V. So Azure Hypervisor is known as Hyper-V. And then we install the OS, and then we create the Azure VM. If it was Amazon, then instead of Azure Hyper-V, what it has, net, something net. So Azure, Amazon has NetX, some net is their hypervisor name, so that they will install it. So other than the Docker or containerization, everyone is actually using that kind of way where they are installing the hardware on top of it, the hypervisor, and then installing the OS on top of it. It was causing a lot of hardware misutilization, but in the Docker, this thing is different. We have same hardware, we installed any OS of our choice, and then put a Docker engine on top of it. As you saw in your colloquium, you installed some Docker software, and on top of it, containers are created. Right. So this is, and whenever it need whatever extra OS facility it wants, it will take from here, and any hardware it can request and it run it. So it was helping the job very well. So now container is basically an empty box. How? It is not installing any OS, and it does not have OS. So how it is installing other software? Because you remember, we need to pass the app, we need to pass the configuration, all the libraries. We also need to pass the operating system and all the configuration. So container is what it is doing. It is taking the images which has all the configuration set. Let's say you want Ubuntu. We can go to Docker Hub. We can go to Docker Hub and we say, let's say CentOS. So CentOS is OS. We can see that it has been downloaded 500 million times, right? CentOS. So this Docker world is getting so much use, half a billion times it has been downloaded, the CentOS. And you simply take the image from this Docker Hub, and it will have the other configuration, like it is a container which has a Linux as a backbone, it's PowerPC, it can run on ARM, etc. And there are container image will be there, which will have other libraries. If we take Python, this can also come, and we can also get a container image with Python and every other libraries is there. Okay. Sorry, thank you. I share the screen. Now can you see it? Thank you. So if we go to the Docker Hub, it is, so whatever things are there, let's say I want to search Ubuntu. Let's say I want to search Ubuntu. So Ubuntu in the Docker Hub, if you name, there is a command, you can run the command docker, pull the image name and bin that bash, then you can get the Ubuntu image. If you had a platform called CentOS, then the CentOS is also there, and you can see 500 million downloads are there. It has been updated 20 minutes ago. So all the recent version and everything is available, and you just get this image, pull the image from the hub and put it in the container, and the container is going to have the image of your running platform. And then this is how people run it. Now, if we go back to the scenario, where DevOps is condition problem was there, right? Now the development team is created a container, and on that every app and every software and OS they have installed it, and they create this image of it, which is a container image of it. And this container image is passed to the operation team and they run on it. Then they will get the exactly the same platform on which the developer team was executing or developed the thing. And then all this trust issue, configuration mismatch, delay, debate, all got minimized, and the things are happening in a very decent and easy way. And that's why Docker is so famous, and Docker is getting used just 7 years, and it has been everywhere. Okay. So it's making the life easy. And what is a Docker Hub? What is a Docker client? We will know next week. And this helping the, now Docker engine is a very lightweight compared to other virtualization option. So if we create this VMware or any kind of VM and we install this hypervisor, and then we create a VM, so we have to actually install the whole OS on it, right? We have to install the complete OS on it, and the Windows OS is usually take 3 GB, right? 3 GB is needed, and then there are more RAM is needed to run it. So it is quite heavyweight. So if we think from the Docker point of view, the Docker engine is a very lightweight. You have installed it. It is a very small in size. And then when you create container in it, that also is a very small in size. And the amount of OS load on container is usually 5% if you are using Linux system. Okay. It will have all the software and dependency. It will simply import from Docker Hub. So Docker Hub is like a marketplace where you simply pull whatever you need and then run it whatever you want, and you don't want it, just remove the Docker image from your system. Then you release all the hardware resources. So when you need it, you do the task and then remove the container. But whenever next time you need create the container, then you already had pulled the Docker, the container image from the Docker Hub. That image is still there in your system. And if you want to again run something on the same platform or same situation or same kind of software and dependency situation, condition, then simply just run the container again. So it is actually better utilization of the hardware, and then it is better than the virtualization for development, testing, and operation platform. And to run Docker is very simple. You say command is like Docker run Ubuntu 10.1. We saw in the right. If we say Ubuntu, so this Ubuntu name is Ubuntu. So this is a name of the container image, Ubuntu. If you want to run Ubuntu debootstrap, or if you have anything else, so take the name of that and then run this command, Docker run Ubuntu, whatever, if it has a version written. Currently it is only Ubuntu there. So you say Ubuntu and then bin bash that command, and then it is simply going to run. There is a command to pull the image and there is a command to run the image. So when you run the image, then it is going to pull and as well as run it. There are some commands are there, like if you go, there are different commands are there in a Docker. It's like you want to run, this is a quick cheat sheet is there. If you want to run Docker container run, the name of the Docker, then it is going to run the Docker. It is a web kind of thing. And then if you are want to stop it, Docker container stop. So this is way you can do it. And in your colloquium, you have probably done build, Docker build. It is going to build an image from the Docker file. So what happened that in a development platform, uh, one has created this, it has a hardware and then OS is installed and then Docker engine is there and is developing the software on the container. Now it took the image from the Docker hub, right? And it built the software, and this Docker image will come with many dependency software, right? Which was there in the image if it is any. And then it is going to build its app, and if any other library is needed or any during the development, if the version upgrade has to be done, it upgraded it. Now after that, it can make an image of it, whatever platform it was running, and it can pass to the uh, testing team or operation team. Then they will have the most recent environment and platform, and on which the program can run easily without a hiccup, without a problem, the way it was running with the developer team. So this is what we have for today.